Here we'll discuss the question number 3 of NBHM 2025. So this is a question from series, and the question is saying that what for what non-zero real case does this series is convergent. So let me write down the series has to be summation fn, where fn is defined by n equal to 2 to infinity. I'm not writing that. Fn is defined by 1 by n to the power 1 plus log of log n over k log n. Now I'm just writing the denominator. Let's see how can I write it. So n to the power 1 plus log of log n by k log n. By using the basic formula of indices, I can write it n into n to the power log of log n by k log n. Now simplified, I'm just writing n into n to the power log e. I'm considering the value of log e has to be 1 into log of log n k log n. Now a to the power log b, that can be written as b to the power log a, right? So I'm just changing it as n to the power log e is whole to the power log of log n over k log n. So this is nothing but, if I apply this formula here, I can write n e to the power log n is whole to the power log of log n by k log n. Now that can be simplified as n into e to the power log n into log of log n by k log n. So I'm cancelling this log n with log n. So this is equal to n e to the power log of log n by k. The same way, if I apply the same formula, I can again write it n log n is whole to the power log e by k. Now the value of log e by k is equal to 1. So this is nothing but n log n is whole to the power 1 by k. So the denominator can be written as, so therefore fn can be written as equal to 1 by n log of n is whole to the power 1 by k. Now considering, first I'm considering 1 by k is when greater than 0. As they are saying k is non-zero, so 1 by k, first I'm taking 1 by k is greater than 0. It means k is greater than 0. Now when k is greater than 0, I can write n log n is whole to the power 1 by k is always greater, sorry, just I can write 1 by n log n is whole to the power 1 by k is less or equals to 1 by n plus 1 is greater or equal to 1 by n plus 1 log of n plus 1 is whole to the power 1 by k. It's very easy, as log n is an increasing function as well as n is an increasing function. So 1 by this is always a decreasing function. So this is a decreasing function. Then by using, we can use the Cauchy condensation test, where by Cauchy condensation test summation fn and summation a to the power n f of a to the power n converges and diverges together, where a is strictly greater than greater than 1 and a is a positive integer, right? So I'm just, that's why I'm just calculating the value 2 to the power n f of 2 to the power n. Let us check. So 2 to the power n f of 2 to the power n, that is equal to 2 to the power n 1 by 2 to the power n into log of 2 to the power n is whole to the power 1 by k. So cancelling this 2 to the power n, 2 to the power n, so what I am having, this is equal to 1 by n to the power 1 by k log of 2 is whole to the power 1 by k. Now this is nothing but the p series, where the value of p is equal to 1 by k. We know that this p series is convergent if p is greater than 1 and diverges for p is less or equals to 1. So p is greater than 1 implies 1 by k is greater than 1, as k is, I have considered k as to be positive, so 1 is greater than k, and we also consider k is less than 0, therefore 0 less k less 1. This is the range when k is positive. Now think that when k is negative, then what I can say that um, if the value of k is more than 0 and less than 1, then this series is convergent. If p is greater than 1, if k is greater than 1, this series is divergent. Now let us consider the case when k is negative, k is less than 0. Now k is less than 0, just intuitively observe that log of n is whole to the power k 1 by k. As k is negative, this is nothing but 1 by log of n is whole to the power 1 by some s type, where s is equal to minus k. This is type. So if we multiply that by, so n into log of n is whole to the power 1 by k, this is, it means we are dividing n by some quantity, so this is lesser than n, right? So if we take its reciprocal, I can write 1 by n is less than 1 by n log of n is whole to the power 1 over k. Now we know that this series is divergent, so this series is also divergent. Therefore this series is convergent only when 0 less k less 1. So hence, so let us move to the question and let's see the answer. It's saying the k is belongs to the interval 0 1. So that's all about our question number 3. Thank you.